Okay, so we've talked about a lot about the types of fisheries and wild caught fisheries in the world, and New Zealand, and recreational, customary, and commercial uses. And now we're going to turn our attention to culturing species of marine organisms and how this fits into the big picture of fisheries and fisheries management. This is an interesting website. I've been looking into introduced plants and animals and the history of people attempting to do that over the years, and we can return to that a little bit later. But it sort of informs the use of bringing animals into New Zealand for culturing purposes. Anyway, so the worldwide situation here. We've been talking about fisheries and the population of the world. We saw that graph in the beginning. The world's population expected to grow from 7.1 billion in 2000 to 8.3 billion in 2030. And actually, I've heard estimates of a little bit higher than that. But that's not very far away if you think about it. That's 18 years from now. Another billion or more people. I think that estimate is revised to more like 2025. So 13 years, we'll have another billion people or so. And right now, the capture fisheries 80 to 100 million tons per year sustainably. It's a lot of arguments against whether that's sustainable or not. The level that we're fishing at the current rate that we're fishing, the current amount that we're extracting from the ocean every year. And so the expected demand is more like 150 million tons. So the shortfall, what's the shortfall there? 50 to 80 million tons. Alright, so where's that all going to come from? So what do you think? Is aquaculture the answer to our fisheries problems worldwide? There's a good point here to turn off the video, jot down a couple of thoughts, and just see if what you know about aquaculture jives with what's going to be presented in the rest of the lecture. Okay, you're back. Alright, so let's have a look at aquaculture. What is it? Let's have a definition to start. Because if we're going to talk about something, we should know what it is. The farming of aquatic organisms, including animals and plants. So it's not just fish, it's not just salmon and mussels, it's all sorts of aquatic organisms. Could be things as small as large as essentially if you have captive dolphins and they give birth, that is essentially aquaculture or maintaining it. If you have but you can also be culturing things like phytoplankton, tiny little single-celled organisms, or maybe spirulina or something like that. And this is also aquaculture. Okay, that definition is from the FAO. But it's not a new concept. People have been culturing aquatic organisms for thousands and thousands of years. So 2000 BC, and there's evidence that possibly as far back as 5,000 years BC, people were keeping fish ponds. Okay, the total world marine aquaculture production, roughly 26 million tons in 2007. It's getting a little bit outdated. That's 5 years old, and it's going up. So at that point in time, 13.5% of the total marine fisheries, and including inland and freshwater fisheries, aquaculture equals 29% of world fisheries production. So that equates to 1 in 5 fish that are eaten, fish or marine organisms, for the dinner table worldwide are farmed in some way. All right. So what do we farm, and how do we go about doing it? If you're going to be further defining aquaculture, you need to include the term intervention. Okay, so if you have a farm and you're farming an organism, in some way you're intervening in the life history of that organism. You may be you may be doing something as simple as releasing eggs into the environment, or releasing fry into the environment and then letting them grow up on their own. Or you may be doing something as intensive as say with maybe a ornamental species. You may be raising it from captive brood stock, from captive adults, having them breed, capturing those organisms, growing them all the way up to adulthood, to the time when you sell them. So it could be intensive or extensive, but the rearing process includes some sort of production or some sort of intervention. And the reason you do that is to enhance the amount of production that you can get out of that population. So the examples: feeding, protection from predators, or breeding and genetics. Farming also implies individual or corporate ownership of the stock being cultivated. So there's no point in doing activities that you don't get any benefit from generally in terms of economic theory. I mean, altruism aside, people don't generally spend their money in order to enhance everybody else's return. Okay, worldwide 210 species recorded. Let's look at some of the bigger ones. So the ones by volume that are big. Oh, well, this is a big fish anyway. This is a carp. Okay. And carp are huge through Asia, some parts of the States, or the Americas, and Africa. Carp are cultured on a widespread basis. You get ponds like this. There's an area in China that is mostly for carp ponds. And when you the good thing about carp, when you are culturing carp, is you can have stocking densities that are just massive compared to other species. There are a few species that are very hardy. They can take high pH. They can take, which would come from the animals pooing and weeing into the water. They can take lower oxygen concentrations from so many fish in the water breathing, or utilizing the oxygen and giving off carbon dioxide. They can just about be put into a sewerage outflow and survive. They're very tough. Same with tilapia. About 100 species of tilapia that are farmed around the world, and these things again can take huge stocking densities. They're freshwater fish. And with the variety of species, then there's usually one that can adapt to the climate in most parts of the world. This is a big species in terms of food fish in Africa and Asia, and also the States. They're illegal to import into New Zealand because certain species, if they got a toehold, would probably do just fine in the native rivers. Omnivores too. These things can be they'll eat vegetarians, or they can be vegetarians. They can eat things like algae or possibly bottom feed, and so they can acquire a lot of the food from the aquatic insects and plants that grow within the ponds. Don't require necessarily pellets or pelletized food and the like. So fairly cheap and easy fish to rear. Okay, catfish. This one is huge in the States. We haven't seen it being cultured here yet, but there is a market for live catfish in Auckland, and they have been they have made their way through the Taupo lakes and through the Waikato River system. The ones that we have are a bullhead catfish here, which don't grow to much more than about 2 kilos. But a 2 kilo fish will give you a nice, nearly just about a just over half kilo fillet, which is very nice for a plate size. So you wind up with something like this. There's a hush puppy and black-eyed peas and some coleslaw. That's a lovely American dish that makes my mouth water. Okay. Clams. Alright, so we've got all sorts of different clams that are cultured around the world. You've got, this is a more of an American, New England kind of surf clam, and then we've got the ones that are being cultured in the tropics for restocking reefs that have been plundered, or for the aquarium trade. Okay, the giant clams. Mussels, the biggest one in New Zealand. Okay, this is the largest by volume in terms of New Zealand. And you can see they're just sit on these ropes. You've probably all seen mussel farms around the Coromandel coast, Great Barrier Island, down in the south in the Marlborough Sounds, and possibly they're looking at exploring offshore mussel farming opportunities on more exposed areas. Okay, so these things eat quite low on the food chain, which is quite good, and they're trying to get some carbon credits actually for these mussels, because every kilo of shell is the majority of shell is something called calcium carbonate, and carbon dioxide has to come out of the atmosphere in order to supply the carbon for the shellfish to grow their shells. Okay, oysters. Okay, this is a typical oyster farm now. You'll see these in places like up in Ohiwa Harbor, a few up in the Northland, more in exposed or more sheltered, non-exposed areas. They tend to be in fairly warm areas as well. And so the oysters, there's a Pacific oyster. They grow in these little baskets that can shake around, so they don't actually attach to anything. And let's say other places like Whangapoa Harbor, there's some lovely oyster farms. We've had problems with these in New Zealand in terms of the water quality in some of our estuaries. Okay, and as filter feeders, obviously, you don't want to be eating things that are filtering out a lot of stuff, shall we say, from poor areas of poor water quality. That's called bioaccumulation. All right, shrimp and prawns, Macrobranchium rosenbergii. These are ones that you would have done your dissections on in the in invertebrates, in an invertebrate lab. These are also the ones that they grow at the Taupo Prawn Park. Some of you may have been there. Got quite a good breeding program, and they are typically a Southeast Asian freshwater species. It's grown in fairly warm water. We don't have to worry about them being a biosecurity risk, because if they get out of the prawn park and into the waterways, generally the waterways are too cold and they won't breed, and they'll just die. Okay, so those are the freshwater shrimp, and are prawns, and then you also have shrimp, which are saltwater, what a lot of people around the world call saltwater prawns. They call them shrimp. So shrimp and prawns, hugely cultured around estuarine and estuarine situations around the world. Lots and lots of deforestation of mangrove forest for shrimp culturing. Okay, sturgeon. All right, this one is on the rise in the States and other places. That's a beautiful white fillet that's much like broadbill. It's fairly steaky. Sturgeon, amongst other species, are cultured for their roe, but also for the mate. And these things get quite big in certain parts of the world. Nearly fished out in the Russian population, where the most expensive roe comes from, the beluga. Okay, but culturing these things not only for restocking but also for meat and roe has become a little more widespread. Okay, salmon. All right, these are largely cultured in cold water environments around the world. Peru, Argentina, not Alaska. Canada does a lot of Atlantic salmon. Scotland, northeast of the United States. Alaska, in order to protect their wild fishery, has banned salmon farming. And so they do have a very healthy salmon population in Alaska. Okay, so this is a picture of a typical New Zealand salmon farming setup in the canals in the South Island. This is around Twizel. This is one of our former students that manages this salmon farm. Graduated 2 years ago, and he. What happens is in these pens, the trout, the salmon are raised because it's quite cold water. These are the canals that go from lakes to hydro stations, so a lot of current, so constantly getting flushed out, and they feed these with pellets, and then so downstream from the salmon farms, you can throw a pellet or a fly or something else, a lure that looks like a pellet, and you'll get things like this salmon and this rainbow trout quite easily. Or no, that's the salmon, sorry, that's a brown trout. So you get the salmon and the brown trout, quite big ones, just downstream of the salmon farms. The escapees, that's what he's catching there. Trout are largely cultured around the world for food in colder water environments. In New Zealand, we don't allow trout culturing for food. They're not allowed to be sold, although there'd probably be quite a bit of scope for trout culture if we did allow it, although of course that leads to some controversy about eutrophication of streams, because these tend to be in sort of cold water natural streams where they are raised. But here we do raise them, and you will probably, if you take aquaculture with next year, go with Daniel to see the trout culturing farm that the Fish and Game runs over in Natawahia, where, not Natawahia, next to Rotorua. Anyway, the Nongataha, where they raise trout in order to restock for the recreational fishery. And finally, another big culturing, but a largely cultured fish is ornamentals. So you can raise things like these Nemos, which you might be able to get $25, $30 for one offspring, one fish. And so you raise these in tanks and sell the offspring to aquarium shops. Okay, we'll leave it at that point, and we will come back. Oh wait, one more slide. Okay, what is farmed? Worldwide 210 species, 90% in Asia. Carp is the biggest. Tilapia, catfish, clams, mussels, oysters, shrimp, sturgeon, trout, and ornamentals. So there's a nice little list for you to be thinking of when you are thinking about quizzes and exams.